Dr. M.K. Murali, Assistant Professor of Physics, J.J. Kalal Arts and Science, Pudukottai. Now we are going to discuss about India Glazer. India Glazer. It is a 4-level solid-state laser system. It obeys the characteristics of light. Power output is 20 kilowatts. Wavelength range is 1.064 micrometer. Nature of output is pulsed. It is a 4-level laser solid state laser system. In India Glazer, ND stands for neodymium ions and YAG stands for yttrium aluminum garnet. NdYAG is a crystal that is used as a lasing medium for solid state laser. It is developed by scientists J.E. Jesik, H.M. Marcos and L.G. Van Wittray in 1964. The NdYAG laser, based on the characters, first one is a active medium, second is a resonant cavity, third one is a pumping source, fourth one is a energy source. Active medium. Neodymium ion act as an active medium or active center. YAG is just the host. Resonator cavity. The end face of the NdYAG rod are ground polished and silvered to act as an optical resonator mirror, or the optical cavity can be formed by using two external refractive mirror M1 and M2. Optical pumping. The figure represents NdYAG laser rod. A flash lamp or krypton flash is used as a pumping source. The optical pumping is used to achieve population immersion. Construction. The systematic diagram of NdYAG laser is as shown in figure given below. The laser rod and a flash tube enclosed inside the ellipsoidal reflector. The end space of the laser rod is coated with silver. One end of the rod is fully reflecting, another end is partially reflecting. The flash tube is connected with the power supply. The external heat produced inside the ellipsoidal reflector is controlled by whether air or cooled water. The NdYAG rod and krypton flash lamp are enclosed inside the ellipsoidal reflector. In order to make the entire flash radiation to focus on the laser rod, the NdYAG rod is placed at one focal axis and the flash lamp at the other focal axis of the ellipsoidal reflector. Working of the NdYAG laser. The NdYAG laser is a 4-level solid state laser system. When the flash lamp is switched on the optical pumping, excited the neodymium ions from the ground energy state E0 to higher energy level E3 and E4 by absorbing a radiation of the wavelength 0.8 micrometer and 0.73 micrometer. Then excited neodymium ion then make the transition from energy level E4 to E2, and it is a non-radioactive transition. The E2 is a metastable state. Upon the continuous excitation, population inversion of neodymium ion is achieved at the metastable state E2. Here population inversion means number of atoms in the higher energy state is greater than for the lower energy state. That one is achieved in the metastable state. Any of the spontaneously emitted photon will make the excited neodymium ion to undergo the transition between the E2 and the E1 state. During the stimulated, the photon is generated. The traveling photons parallel to the resonator axis experience multiple reflection at the mirrors. As a result, the transition U2 to E1 yield the intense and coherent laser beam of wavelength 1.064 micrometer. That is the slide shows the energy level diagram of the NDR laser. There is a 4-level laser system. The neodymium ions that make the transition between the E1 to E0 when is a non-radioactive transition. Only part of the energies by the flash lamp is used to excite the neodymium ions, while the rest heat up the crystal. Thus, the system can be cooled by either air or water circulation. Application: the NDR laser is used in industry, communication, military purpose. Another one is for the medical. In industry, the lasers are widely used for cutting, drilling, welding, and surface hardening of the industrial product. It is used in a military as a range finder and target the destination. In medical field, it is used in a medical field for cataract surgery or to treat the gastrointestinal bleeding and gallbladder surgery. It is also used in a health communication. It is used in the study of inertial confinement fission. That is, you are used in for the reactor. Thank you.